How many of you know about Docker? How many of you know about Docker? As I told again, classes will be on Thursday, Friday, Saturday. Okay. How many of you know about Docker or heard about Docker? How many of you know about Docker or heard about Docker? Anyone can tell? I mean, type in the chat. Have you heard about Docker? Yeah. Only one person I saw the response. What about others? I mean, you don't need to tell about what is Docker, but how many of you heard at least there is a tool, there is a tool or library or concept called Docker. Okay. One of the tool in DevOps course. Okay. All right. Okay. How many of you heard about or how many of you heard or know about virtual machine? Virtual machine. Okay. All right then. Okay, how many of you heard or know about physical machine? This everyone knows, right? Everyone knows this, right? Because you are working on, you joined this class through this your physical machine laptops, right? If no one is joining from mobiles, you joined this from your laptops or desktops. So these are your laptops or desktops, right? This I think everyone should know. Otherwise, you cannot attend this class and you cannot practice the programs, right? Okay. Now, what do physical machine contains? It is a physical machine. This physical machine contains, if you take, okay, a processing unit, which is called CPU. And then there will be a secondary memory. So which is also called hard disk. There will be a primary memory. Which is also called RAM. Right? In addition to this, a primary memory, which is a RAM. In addition to this, in addition to this, there is an operating system, right? Which is your Windows or Linux. Right? So these are physical machine. And the user, the user of the physical machine, any instructions to the physical machine will go through the operating system. Any instructions. So for example, he wants to connect to the hard disk, or he wants to save some file to hard disk. So that calls will go from operating system to this. Okay. Similarly, if he's running a program, the program will be stored in the primary memory, RAM. Okay. So this will store, the secondary memory will store permanent data. And this stores temporary data. This stores temporary data. Example, a program will be running. Okay. Or a program data will be stored. Or we can select this, a program temporary data will be stored. Like variables, etc. in RAM. Once the program exits, once the program gets completed, all the variables, will be erased. A program temporary data like variables, etc. in RAM, once program gets completed, all the variables will be erased. So that is what in the RAM it is stored. And your secondary memory is hard disk stores permanent data, like your whatever your data you are storing in C drive, your D drive. These are all part of your hard disk. And any call will go through this operating system. And what processing unit does? It does the execution of any process or program. Okay. So I'll tell you how a simple program works. Suppose you have written, so what you do is, say for example, you have written a program, simple program like a.java. This a.java, so where you will store? You will store that in, once you store that in a hard disk. Once you have written, you will save that to hard disk. Now, when you compile the program, even the compiled program also will be stored in hard disk after compilation. Compiled program also will be stored in hard disk. Right? Now when you run the program, okay. So in Java, what you do in Java, what will happen is there is a concept called, there is a software called JVM, which is called Java Virtual Machine. This is Java virtual machine. How you will get it is when you install JDK. When you install JDK, there is a combination of Java compiler plus Java virtual machine. Okay, the Java virtual machine. When you run the, so when you come first, you have written a.java. So with the Java compiler, you compile the Java file, and that got created to a.class, which is called compiled version. a.java, after compilation, it got converted to a.class. And now when you run the program, when you run the program, which is Java A. Okay, when you run the program, which is actually Java A, you know what actually the Java, so what will happen is the Java virtual machine will be loaded in the primary memory. The Java virtual machine will be loaded in a primary memory. JVM is loaded in primary memory. And you know what it does now? It will read, once JVM is loaded in primary memory, and so that means it will bring this class file from your hard disk to RAM, okay, just for a temporary purpose, and it will start reading byte by byte. JVM will start reading or interpreting, or we can say like this, start converting each line of the class file to machine instruction. To machine instruction. Okay. And where this instruction will be stored? So machine instruction. Now the CPU will use a system bus internally like this. There is a concept called here system bus. Okay. Or we can tell like this. So it will put in a machine instruction, and the machine instruction will be put in this system bus actually. That instruction will be put in the system bus. Instruction means, for example, that program contains add, that program contains multiplication, that program contains subtraction. What are the calculations or for loops or whatever the instructions that program has, all that are part of your machine instruction, all that are part of instructions, and your processing unit will understand only the machine instruction, the machine code. And those machine instructions are put in the system bus. And CPU, you know what it does? It will take those instructions, and here they have digital circuits. They have digital circuits. CPU has internally built with digital circuits. digital circuits. How many of you have heard about in your engineering or academics like digital logic design? How many of you have heard of studied this subject, digital logic design? Adders, subtractors, multiplexers. How many of you, right? So that subject is this one, where it does all the processing and all. So processing unit process the execution of the instruction and provides the result. And where that result is stored again in the RAM. So once, unless and until you write the program to a file, files will be stored in the hard disk, but all the variables data, int a equal to 2, int b equal to 3, all those variables, whatever you are writing, int a equal to 2, int b equal to 3, all these are variables, right? So these will be stored in the RAM actually. Right? So this is how a physical machine will work. And how JVM is loaded in primary memory? That is with the help of operating system. With the help of operating system, JVM is loaded in primary memory. So that means when you install the Java software, it will be located in the hard disk. And when you start running the Java program, operating system brings the JVM to the primary memory and starts converting each line of the .class file to machine instruction. And each instruction put in the system bus. The processing unit will take the instruction from the system bus and will do the processing of the instructions. So this is how the physical machine works. Okay? Everyone understood? Because this is, you should know, actually, you are writing so many programs you'll be working on, right? Internally, you should know how a program works by your computer works. Your computer will process your program. Right? Fine. Now, this is a physical machine. Which contains your operating system. Next is your CPU, your RAM, and your hard disk. Now, on top of this physical machine, okay, I'll tell you one simple. There is a software called hypervisor. There is a software called hypervisor. So hypervisor is a software that creates logical or virtual, or that creates or is a software that creates virtual machines. on top of physical machine. And what is a virtual machine is? A virtual machine is a software. A virtual machine is a software that behaves like physical computer or physical machine. Physical machine is your hardware, your real hardware machine built on a hardware. See, this is your hardware. So this is your hardware. This is your hardware. Okay, this is your hardware. And of course, OS is a software. Yes, this is a software. And these are all your hardwares. Right? So that means on top of physical machine, the hypervisor is a component, or it's also a software that creates virtual machines on top of physical machine. That means, what is a virtual machine? It's a software that behaves like a physical machine. That means, let us take one physical machine. Say hypervisor created a virtual machine. Okay. So this is a virtual machine. So this virtual machine will have a OS, a CPU, a RAM, everything, whatever this has. But these are all not physical CPU or physical RAM. Okay. These are all virtual CPUs. Virtual means this CPU is a hardware. Now this has been converted to a software. That is a program, this is a program. This is virtual CPU we call. So this is a program that works like CPU. But internally, it uses physical CPU. Program that works like CPU, but internally uses physical CPU. Okay. Similarly, it will have its own RAM. Okay. And again, this RAM is also virtual RAM. RAM means it is a program that works like a RAM. Like a RAM. And internally uses physical RAM. And internal uses physical RAM. Similarly, it also has hard disk. Hard disk. So again, this is a virtual hard disk. Which works like a virtual means, when I say virtual means, you can think it is a program or a software. See, that means this physical machine, that means I'll use this physical machine. The concept is inside this physical machine, I can create Java programs, right? Java or C or Python programs, right? And execute. And what is the purpose of this C, Java, Python programs? To get some output, right? To get some output. Similarly, inside the physical machine, software has been written or programs have been written to create virtual machines. I mean, from physical machine, we can create a program that works like to create a virtual machine that works like physical machine. See how the concept has been built. And how that will done, how that is done, that is a hypervisor is a component that will do this. That will hypervisor is again a program. We can think like hypervisor written some language like C or C language or some language. So this is a program that is running in the physical machine that can create this virtual machine. And this is a software. There is no physical identity for this, but this will work like a physical machine. And I can create on a single physical machine multiple virtual machines. And directly an user can access this virtual machine. Just like how we are using physical machine, a user can access virtual machine and he can work on this. But this is not a real hardware. This is a software. But for the user, he thinks like that he's working with a computer, but internally that he's using the underlying physical machine. And this concept is used by cloud actually. Cloud computing. So this concept is used by cloud computing. Cloud computing uses this virtual machine concept. And in each virtual machine, I can have separate OS actually. OS is a software only, right? I can have separate OS. Say your physical machine OS is, say Linux, Red Hat Linux. Now, in my virtual machine, one virtual machine I can have OS as Ubuntu. Next, in another OS, I can have Windows. Another OS I can have, okay. I can have like Debian Linux. So like this, the operating systems can be different for each virtual machine. Okay. But the CPU RAM also will be different for each virtual machine. But they will internally be using the physical RAM, physical hard disk, CPU internally, which the end user doesn't care. The end user will be operating on this machine as if he's working with a physical computer. In cloud computing, how that is possible? In cloud, you don't have Cloud is like, for example, you have AWS, Google, Google Cloud, and then Azure. Right? So all these are possible. And they use this predominantly this virtual machine concept. The end user will be working on the virtual machine, but they are built on physical machine. This is what the virtual machine concept. That means in the cloud computing, I can take this virtual machine and I can install all the softwares in this virtual machine, Java software, database, everything as if I'm installing in the physical machine, and I can work on this virtual machine. And this virtual machine will have an IP address. If you go to cloud, you can log into this IP address. You can use SSH to IP address. You can work on this machine. You can install all the required softwares like your Java or Python or database, and you can write programs, you can store the data, everything, as if like a physical computer. But see, that is a software. Actually, that is a whatever you are working on the virtual machine is a software. The software is working like a physical machine. Okay. See, in cloud, if you take the physical machines, all have. If you take the physical machines are also even distributed. 2 or 3 physical machines combined to give multiple versions. The RAMs are very heavy RAMs. Okay. Like, for example, even there are RAMs internally, they are using 1 terabyte RAM, and that is distributed to virtual machines like 128 GB, 256 GB RAM. Okay. So based on the capacity of the physical machine they have, they can create those many virtual machines. And if they want to create physical, they'll extend the physical machines also internally. Okay, they can extend these physical machines. And hypervisor, one good concept is the best example of hypervisor. Hypervisor was first developed by VMware. So VMware created this hypervisor. So your physical machine is having that much capacity, they'll have that much capacity to create the virtual machines. Like that, they combine 2 or 3 physical machines, multiple physical machines, to build virtual machines. So like that, this virtual machine concept will work. So if you take this concept, so this is my physical machine. On top of this physical machine, you have hypervisor. On top of this hypervisor, you have virtual machines. You have virtual machines. On each virtual machine, say you can think like this. This physical machine will have host OS, operating system. Host OS, operating system. and each virtual machine will have guest OS. Guest OS. This is called guest operating system. Because if your physical machine has one operating system, in virtual machines you can install, you can have separate operating systems. And virtual machines are very heavy. Are heavy because they carry the overhead of separate operating system. They carry the overhead of separate operating system. An operating system itself will occupy nearly 400 MB, 500 MB of space. So operating system is heavy. So they carry the separate operating system overhead. That's why they are not lightweight. They are very heavy. They are not lightweight. Now there came another concept similar to virtual machine. They thought that because of operating system, right, this virtual machine concept has become very heavy. Why can't actually we do in this way? There will be a physical machine. Okay. And this will have, or even you can think like a physical machine or virtual machine. Now, physical machine or virtual machine. On top of these, there comes multiple containers. Multiple containers. Multiple containers. And these containers also work like, physical machines or virtual machines. Okay, but these are also software. Okay, and these containers will have its own CPU, will have its own RAM, everything. But internally, they share the final hardware of physical machine. So these containers will have their own CPU, memory, and finally they share. Say this physical machine will have some operating system, right, which is called host operating system. Host operating system. But these containers, we call this as a containers, will share the same operating system. These containers will not have separate operating system like physical machines. So these containers will share the same operating system as host operating system. They will not have separate operating system. And how that is possible? This is through containers. Just like hypervisor, how it creates virtual machines, there will be a container engine. There will be a container engine that creates containers. And the famous container engine is Docker. Docker container. So the famous is Docker. So with the Docker container engine, we can create multiple containers machine that share the same operating system as host is. They'll not have separate ones. Since these containers doesn't have overhead of maintaining separate operating system, these are very lightweight actually. So containers are lightweight. As they don't have separate overhead of maintaining operating system. Containers are lightweight as they don't have separate overhead of maintaining operating system. And that's why Docker is popular because it's a lightweight and it can be shipped from one system to another place, portable. It is easily portable and thereby it doesn't need separate operating system. That means a container, what container contains means mainly container contains. What does container contain? It mainly contains applications, libraries. Okay. The container contains that one. It's a bundle of applications and libraries that share the same operating system as of the host operating system. Okay, but each container will have its own IP address, virtual file system, virtual hard drive or virtual hard drive. Okay. I mean, we'll share virtual hard drive, virtual RAM. So like that. And the famous software that creates containers is Docker. And a container can be created. Containers can be created on a physical machine or virtual machine. And containers work only in Linux OS. Works only in Linux OS. That means, say for example, your physical machine is Windows. Your physical machine is Windows. On top of this physical machine, you cannot create containers because Windows will not support. So Windows will not support containers. So you can have a virtual box. Virtual box on the inside virtual box, you can install Ubuntu or Okay, you can like Ubuntu is a Linux zone, and install Ubuntu. Then you can install Docker. Yeah, Windows 10 supports internally. Again, it uses internal VirtualBox. Actually, see, Windows 10 there is a support for Dockers, but still I believe all the full-fledged Docker support is not provided by Windows. That's why I don't prefer directly using the Docker directly in Windows. I always use Linux OS or Mac. Even if you have Mac also, better to use. I will not prefer directly Windows 10 to go for Dockers. Even some performance issues are also there. And remember, one virtual machine cannot connect to another virtual machine directly. That will happen. Even one container will not connect to one container directly. There is as if you are working on two systems. They can connect only through network. They can connect only through network. Even the virtual machines also, they can connect only through network. As if they are two physical computers. How your two physical computers cannot connect directly? They can connect only through network only. Okay. And how this container concept has been built is, this container concept is built on concept of, if anyone asks in interview, you can tell that container concept is built on around Linux file system groups. Linux file system group. Using Linux file system group, you're able to achieve container concept, sharing the same operating system as of your physical machine or virtual machine, and having separate resources where one container is separated from other container. Okay. So using Linux file system group, able to share same operating system, able to share same OS, okay, but isolated among each other. But containers isolates among each other, but each container is isolated with other container, having separate IP address, okay, separate everything, separate memory, etc. Everything, as if like a physical computer. If anyone asks how the container concept is built, you can tell like it is built around Linux file system. That's why container works in operating system Linux. All right. So tomorrow I'll show you how to set up Docker, how to install Docker, and how we'll work with Docker programs. Okay, Docker instructions and all that. Anyone is having any doubts till now? Any questions? Any questions? Yeah, just 1 minute. So see, Docker is actually a software that creates the containers, and we can have same OS multiple times as we want in VM, right? Yeah, we can have multiple containers, and each container can have different OS. I mean, they share the same operating system as your base. So whatever your host operating system is there, the same OS will be there in the containers. You cannot have different OSs, just like VMs. Because containers works on the Linux environment. Docker, see, Docker in one line is Docker is a software that creates the containers. What is a container? Container is a software that works like a virtual machine, but it will share the same operating system as the host operating system. All right, then, tomorrow we'll see.
mad Hindu.